We want to evaluate the line integral of x cubed y squared along the curve C with respect to x. So notice how for this line integral, we are not integrating with respect to s or arc length, we're integrating only with respect to x. Where the curve C is the arc of the curve x equals y squared from the point 0, 0 to the point 1, 1. So let's first take a look at the curve C in the xy plane. Here we have the graph of x equals y squared. Notice how this point at the origin is the point 0, 0, and this point is the point 1, 1. So this is the path of integration, but we're only integrating with respect to x, not arc length. So to evaluate this line integral, looking at our notes below, the integral of f of x, y along the curve C with respect to x is equal to the integral from a to b of f of x of t, y of t times x prime of t dt. So we need to write the integrand function given as a function of x and y as a function of t using the parametric equations for the curve C, and then differential x is equal to x prime of t dt. So because the given curve is x equals y squared, for the parametric equations, let's let y, or y of t, be equal to t, and therefore x, or x of t, is equal to t squared. Now to trace out this curve from this point to this point, notice how we'd have to let t be on the closed interval from 0 to 1. So t is greater than or equal to 0 and less than or equal to 1 to trace out the curve C. Now for the next step, let's find f of x of t, y of t. So f of x of t, y of t is equal to, well, if f of x, y equals x cubed y squared, x cubed in terms of t would be t to the second to the third, and then y squared would just be t to the second. So simplifying here, we have t to the sixth times t squared, which equals t to the eighth. Notice how we also need to find x prime of t. Well, if x of t equals t squared, x prime of t is equal to 2t. And now we have all the information we need in order to evaluate the given line integral. The given line integral of x cubed y squared along the curve C integrated with respect to x is equal to the integral of f of x of t, y of t, which is t to the eighth, times x prime of t dt, which would be 2t dt. And now for limits of integration for t, we'll integrate from 0 to 1 to trace out this curve. So simplifying, we have the integral from 0 to 1 of 2t to the ninth dt. Let's go and evaluate this on the next slide. The antiderivative is going to be 2 times t to the 10th divided by 10. Well, 2/10 simplifies to 1/5, so we have 1/5 times the quantity. When t is 1, we'd have 1 to the 10th. And when t is 0, we just have 0 to the 10th, which gives us 1/5 times 1, or just 1/5. This is the value of the given line integral. I hope you found this helpful.